Both of you touched on something that one of our registrants asked. Pascal asked how artificial intelligence can support automation. How can artificial intelligence support automation? Are there any concrete examples that you could point to about the ways that we're currently using AI to further automation?
Sure.
I can just go ahead, Matt.
Maybe start and then kick it off to TJ. AI and ML has definitely become like a hot topic for sure in almost every industry nowadays. And I think it has impacted automation in more of a roundabout way. Of course, it depends on how you define the terms, but largely at Beam, automation is used as a means to kind of create these really large scale data sets that are used for like model training. We have a few applications now that, due to the just massive amounts of data that we're able to generate on these systems, our models are actually successfully predicting outcomes of different experiments in various therapeutic areas. Beam is a base editing company, and some examples of applications in our area revolve really around optimizing on-target edits. And we have a lot of knobs that we can turn in the design of the protein that's performing the actual editing itself. How do we find better targeting so that we're making the edit where we want to? So we can actually tweak things like the design of the molecule, the sequence that we're using to guide our actual editor, and even optimizing different delivery modalities. We can have the best editing in the world, but if we can't get our drug product to the tissue that we want to do the edit on, it doesn't help us a lot. So we're able to really generate these models that help filter through the infinite combinations of stuff that is out there. So from a purely automation perspective, there's some really cool work, around vision-based systems and kind of hands-off analysis like learning algorithms for machine performance. But from what I've seen so far, that's largely how Beam uses AI and ML, but definitely excited to see kind of how we push that envelope closer to the robotic systems themselves.
Yeah, I could also chime in that designing, Excision is also a gene editing company targeting virus, where we've got multiplex editing and want to look at specificity and targeting. So there's a lot done before the automation and screening steps. And so that certainly is something that Matt touched on. But I think what's more interesting in some ways is how we can do these experiments with the part that Matt was getting into about the data automation. Talking to friends in the industry recently, on a similar topic in another meeting where we were presenting on this, we were talking about how having machine learning, looking at the data as it's coming off the experiment, can allow you in real time to do some analysis. As Matt mentioned, you can predict what you expect the outcomes, you can tune the experiments. And in some examples from a past life, we actually learned that a machine wasn't functioning properly. And so instead of running a whole set of experiments, once you're got a I guess I can skip exactly what was wrong with this one machine, but one small problem, you're able to hold it up, go in, switch to another redundant machine, or fix it. So there's a lot that can be done in automation, but I think what's really the exciting is what's done before and after, looking designing better experiments and gene targeting protocols, and looking at the data. But the fact that it really is now immersed into data automation, coupling with our systems for doing these kind of LIMS things, is really part that wasn't really thought about too long ago, but is really changing things up.